Okay, this is a video regarding questions that have been coming up on Unit 7, which is about evaluating trig functions, and specifically in this case, inverse trig functions. Um, Inverse trig functions, the idea here is you're trying to find the angle that has the given value. So this, when you see this, first of all, this syntax, it's saying what angle has a value for the sine of negative square root of 2 over 2, right? Um, Now, with the inverse sine function, what you want to remember is, from the high school realm, in order to make this a function, we define the inverse sine on a different domain than 0 to, say, 360, or even 0 to 180, 0 to pi radians. We define this to go from negative pi over 2, negative 90 degrees, to pi over 2. Okay? And the reason for that is, if we don't, then the inverse graph ends up repeating on itself. That's to say, normally, if you think of going from 0 radians to 2 pi radians, the sine function looks like this. Okay. And so when you form an inverse function, right? Inverse, you reverse the xy values, the xy pairs. Okay. The x becomes the y and the y becomes the x. Well, if you were to do that with the ordinary sine function graphed from 0 to 2 pi radians, you would end up with a graph that would look like this, right? So 0, 0 would still be 0, 0. This point, which is pi over 2, 1, right? This point at the top of that hill right there. That point is going to correspond to 1, comma, pi over 2. And so the problem you can see, if you think of the inverse this way, by reversing the x and the y's, is you don't have a function anymore, right? Because here's my y-axis, and you're not going to pass the vertical line test, all right? So what we do to make the inverse be a function so that the vertical line test can be passed is we restrict our domain, and we restrict it on the sine so that it's running from negative pi over 2 to pi over 2. All right. Now the sine graph, of course, 0 to 90 degrees is going to look like that. It's going to be identical to what you're seeing up here, right? It's going to be that same graph. From negative pi over 2 to 0, it's going to look like this section right in here, right? Because the sine graph is cyclical. It repeats itself. And so there is y equals sine x for x between negative pi over 2 and pi over 2 that you probably remember from high school. Well, now, because we're restricting the domain on the sine function, when you form your inverse, now we'll have a function. Of course, we're still going to get this first part here, right? So we'll still have our pi over 2 comma 1 will be mapped to 1 pi over 2. That'll still work. And now all these other values they're going to fall right in here. So I made that the wrong way. Sorry about that. Let me just patch that up. I want that to go this way. So this point back here, which was at on the regular sine function at negative pi over 2 comma negative 1, is now at negative 1 negative pi over 2. All right. And the advantage is now when you look at your inverse trig function, you now have a true function. There's no doubles created on the y. It passes the vertical line test now. If we use the 0 to 2 pi graph and try to reflect it, you end up with this thing that kind of looks like an S, and so you fail the vertical line test. So what we do is we restrict the domain and say that our answer is now going to come from negative pi over 2, negative 90 to 90. All right, so that's the first hurdle to cross. So if I just wipe that out, and if you're understanding that, then the rest of this goes pretty easy because we just reverse the technique for finding the sine of an angle. And the first thing I notice, okay, is that the value is negative. So the angle will be less than 90. Sorry, less than 0. It will be a negative angle. All right. In other words, on that graph I just had here a moment ago, right? Since I'm seeing a value of negative square root of 2 over 2, I know that my answer is going to be somewhere back in here, right? Now, the negative square root of 2 over 2, okay, we've determined that it's going to be before 0. It's going to be somewhere from negative pi over 2 to 0. It's going to lie somewhere in that region. And then the square root of 2 over 2, what angle, ask yourself the question, what angle has a sine square root of 2 over 2? Well, if you can use your chart or use your reference triangle or use your unit circle, whatever way you're doing this, you should remember that that's 45 degrees if you're thinking in degrees. Now, of course, in radians, that's pi over 4. So the angle that will give you a sine of square root of 2 over 2 is the pi over 4 angle. But again, it's negative, so we know it has to be before you get to 0 in order to make it negative. And so our final answer is negative pi over 4. All right. So evaluating these inverse trig functions, you need to make sure of where the angle is placed. And then from whatever method you use going forward when you're evaluating the sine, the cosine, or the tangent of a given angle, you need to recognize those reference numbers some way, either by using your unit circle or using your reference triangles, your 30, 60, 90, or your 45, 45, 90. Or maybe you've memorized the chart that was suggested in the previous video. Whatever way you're doing that, that's how you determine the absolute, as in positive, value of the angle. And then you just put on whatever SIGN, whether it's plus or minus, in order to determine where you lie. Now, when you go to cosine, it it can change a little bit because, and that's what that exercise number 9 is about. Because if you look at the cosine graph, right, it doesn't have the same issue that the sine graph had. If we graph cosine, cosine of 0 is 1. And then when you get to pi over 2, when you get to 90 degrees, the cosine reaches 0. So in the first quadrant, the cosine graph does this. And then as you move towards pi radians, as you move towards 180 degrees, it approaches -1. So the graph kind of looks like this from 0 to pi. And so again, I'm going to restrict the domain when I do cosine inverse. Okay, here's y equals cosine x from 0 to pi radians. Well, if you do the inverse cosine, if you make the y the x and the x the y, right, then that graph will look something like this, right? The point right here, which was 0, 1, is now right here at 1, 0. The point that was at pi over 2, right here at this point, pi over 2, 0, is now at 0, pi over 2. And similarly with this point here, which is at pi -1, it's now at -1 and pi. And you'll notice that we pass the vertical line test. So we will be fine when we do the inverse cosine by using a restricted domain. Yes, we've restricted the domain, but we didn't have to go back into negative space to do it. The restricted domain on the cosine function is merely from 0 to pi radians. Okay, so your answers out of these evaluate inverse cosine functions are going to come from 0 to pi radians. All right, now since this angle is negative, right, since the evaluation is negative, I know that my angle would have to be between 90 and 180 degrees, between pi over 2 and pi radians. All right, you're right here. I'm thinking negative cosine. My answer must be second quadrant. Okay. The only way to have a cosine end up negative is if you're beyond 90 degrees, right? It's negative. It's below the x-axis. So that negative value is telling me that. Okay. Then I recognize, okay, I just recognize cosine square root of 3 over 2, okay, either by remembering your chart or using your unit circle and looking at the x values because you want the cosine value, or perhaps you use the reference triangle, the 30 60 90 or the 45 45 90. Of course, in this case it would be the 30 60 90, right? So if you do it by reference triangle, it would look sort of like this. This is a 1, this is a 2, this is a square root of 3. Um, this would be your 30-degree angle. This would be your 60-degree angle, right? So which angle has a cosine of square root of 3 over 2? Well, cosine is adjacent over hypotenuse. So which angle has an adjacent side of square root of 3 and a hypotenuse of 2? And of course, you recognize that as 30 degrees. Now, from there, I know the answer is 30 degrees. I know the answer is pi over 6 if you're thinking radians. Okay. But I've got to put that 30-degree angle in that second quadrant, right? So to do that, what's 30 degrees in the second quadrant? What's pi over 6 in the second quadrant? Well, 30-degree reference angle means a forward rotation from standard position of 150 degrees. Okay, so this is going to correspond to a second quadrant answer of 150 degrees, which would be a correct answer, except we want it in radians. So you need to remember how to convert radians to degrees, and that turns out to be 5 pi over 6. So there's some examples of, and hopefully refreshing your memory on how to deal with inverse uh, cosine, inverse sine. We didn't talk about inverse tangent. Um, the inverse tangent graph, to grasp that idea, again, look at the straight tangent graph, right? Look at f of x equals tan x. Well, f of x equals tan x is a graph that looks, roughly speaking, something like this. It ends up with some vertical asymptotes, you may recall, from Algebra 2 and trigonometry, right? And then it comes up like this. The tangent of 90 degrees is undefined, and so it jumps and skips, and then in quadrant 2 it comes up from the negative. It zeroes out when you get to pi radians, zeroes out at 180 degrees, and then it repeats, right? In quadrant 3 you get an exact copy of what you just saw in quadrant 1. Here's quadrant 1, here's 2 where the sign is positive, right? And cosecant. Here's quadrant 3. Quadrant 3, the tangent is positive, and then it is a repeat of quadrant 1. It's an exact copy, okay? And then quadrant 4, again, tangent does the same trick, and so it comes up from the negative and zeroes out when you get back to 2 pi. So can you see how we want to restrict so that f inverse, right? So that tan inverse becomes a function, right? What do you want this to look like so that when you basically turn it 90 degrees, actually 90 degrees and flip it, but anyway, turn it 90 degrees so that it will still be a function? Well, we restrict the domain so that it goes from 0, from negative pi over 2 to pi over 2, just the same as we did with the sine. Again, think back to what's back here, just like we did with the sine. Since these graphs are all cyclical, they just repeat. And so this portion you're seeing right here is going to be back here. If you go back to negative pi over 2 and start down here, come up there, you now have your uh, idea of what inverse tangent would look like. Now, even though if you only went from 0 to pi, you'd say, well, I'd still have a function. But the problem is you have a gap in it, which for reasons to be explained later, we don't want. At 90 degrees, right in the middle of the graph, if you turn this thing side, you have this vertical asymptote, and you'd have what we call a discontinuity in the calculus. And so in order to avoid that discontinuity, we restrict our domain to go from negative 90 to pi over 2 to 90, so that way it's one continuous graph. All right. So that's a little bit on inverse trig functions and how to evaluate them. If you need more help with that, just get back to us, let us know. It is a refresher from high school, so hopefully this has been enough to do that. But if not, get back to us, let us know. We'll try to help you out.